We're going to examine how to find the area of regular polygons that are hexagons. I'm going to introduce you to what regular hexagons are. Then we'll talk about something called the apothem, or some may call it apothem. And then we're going to use all that information to examine the steps to find the area of a regular hexagon. And then we'll do some examples together applying the steps. What is a regular hexagon? A regular hexagon is a six-sided polygon in which all sides are equal, or you can say they are congruent. And because all the sides are congruent, all the interior angles are also congruent. The interior angles are congruent as well. And so you can see here, based on that definition, A, B, C, D, E, F, this polygon is a regular hexagon, six sides, congruent interior angles, and as an extension, congruent exterior angles. What is the apothem? The apothem of a polygon is a line segment from the center of the polygon to the midpoint of a side of the polygon. So you can see here, this line OM is an apothem of this polygon. We could also come up with another one from here, over here. This is another apothem. The most important thing is it's from the center of the side of the polygon to the center of the polygon. You can also look at it as the altitude of a triangle that is formed when you draw a line from the end of the side of the polygon to the center of the polygon. So here, OM is your apothem. The apothem is very important whenever you're trying to find the area of any polygon, regular polygon that is. So how do we go about finding the area of a hexagon? We want to first find the length of the apothem, then we want to find the perimeter of the hexagon. And to find the length of the apothem, you have to make sure that you remember some important properties of, you want to understand some important properties of the polygon, and also you want to apply your understanding of 30, 60, 90 triangles here as well. So how do we go about finding the area of the apothem? It is 1/2 multiplied by the perimeter of the polygon, in this case a hexagon, and then we'll multiply that by the length of the apothem. So the other way you could do it is you can just create a triangle from the center of the hexagon to one side of the hexagon, find the length of the apothem, so you cannot escape understanding how to find the apothem. Find the length of the apothem, and then you'll find the area of that triangle, and you'll multiply that area by the number of sides. So let's go ahead and do that. It's going to be pretty easy to do. I'll show you a few examples how we apply this. So let's go with this one here. What I'm going to do here is I'm going to use the alternative method. So find the length of the apothem of a regular hexagon, given that the tan of 30 degrees is square root of 3/3 and the tan of 60 is the square root of 3. What I'm going to do here is I'm going to use a 30, 60, 90 triangle method here. So let's assume, so we're going to make an assumption this is our center right here, and then we're going to draw some lines. Let's draw a line from here to here, and another line from here all the way here. And then we're going to draw our apothem, which is the line from the center down here. Okay, so what we're going to remember here is that because we have a hexagon, each of these angles is 120 degrees. How do we find that? Well, you can simply do is 180 minus 360 divided by number of sides, which is 6, which is 180 minus 60, which is 120. So we now have, this is going to be 4 here, this is going to be 4 here. If this is 120, this is going to be 60, this is going to be 30. And we need the information here to find the apothem. So you can see here that we have the side opposite 60, the side opposite 30 is actually 1/2 of your hypotenuse, but then the side opposite 60, which is our apothem, is going to be the square root of 3 multiplied by the side opposite 30. So this is going to be 4 square root of 3. So now we're going to find the area of the triangle. Area of the triangle is going to be 1/2. Our base is 8. Our height is 4 square root of 3. So this is going to give us 4 multiplied by 4 square root of 3, which is equal to 16 square root of 3. And then we say that we multiply this by the number of sides that the hexagon has, which is 6, which is going to be, so the area, this is the area of a triangle, so area of polygon is going to be equal to 16 square root of 3 multiplied by 6, which is equal to 96 square root of 3. And let's go to another example. Find the area of a regular hexagon given that its apothem is 5.6 inches and the length of one of the sides is 9 inches. So the area in this case is 1/2 multiplied by the perimeter of the polygon, and then we multiply that by the length of the apothem. So this is going to be 1/2 multiplied by, the perimeter is going to be 9 multiplied by 6, because there are 6 sides and each of them is 9 inches long, and then we'll multiply this by 5.6. So this is going to be, we can cancel this out, we have 3, so we have 27 multiplied by 5.6. You can use your calculator at this point, but I'm not always a big fan of running to the calculator, so 27, 5.6, we have 162, 135, this is 0, 0, add this, we have 2, we have 1, 5, 1, and then we have 1 decimal, so this is going to be 151.2 square inches. And let's do a final example. Find the area of the regular hexagon given that, so you have all of this information. So we're going to use, in this case, I'm going to use all of this information that's been provided. So here, let's go ahead and draw our lines here. Let's draw a line here and draw a line over here. And then we know, based on what we discussed earlier, that this is going to be 60, this is going to be 30, and this is 9 over here, this is 9, and we want to find, let's call this h. This h over here, how do we get that? We're going to use tan, so tan 60 is equal to opposite over adjacent, and tan 60 is the square root of 3, so h is equal to 9 multiplied by square root of 3, which is 9 square root of 3. And so I'm going to show you, we're going to apply the 2 different methods here. So we have 1/2 multiplied by perimeter multiplied by apothem. So that's the area here, which is going to be 1/2 multiplied by 18 multiplied by 6, and then our apothem is 9 square root of 3. So let's go ahead and do this. We have 54 multiplied by 9, so that is 486 square root of 3. So that's one method. The second method we're going to apply is using the area. So the area of the triangle, is 1/2 base multiplied by height, which is 1/2 of 18 multiplied by 9 square root of 3. So this is going to be 81 square root of 3. And then the area of the polygon is going to be the area of the triangle, which is 81 square root of 3 multiplied by the number of sides of the polygon here, which is 6, which is going to give you 486 square root of 3. So you can see that either of these methods will get you to your correct answer.